Hello everyone. In this video, we are going to look at a very simple problem of linked list. We are given a linked list and we want to insert a new node at the head of the list. In this case, let's assume that our linked list has these values 5, 7, 10 and 12. It is sorted. It may or may not be sorted though. And we want to insert a new value, let's say with 3. So if we want to insert a new value, essentially what should happen is that we should create a new node with the value 3. Then 3 should be the first node, which means that the head should be pointing here. And the second node should be the current first node, which means that next of 3 should point to 5. And because the head is pointing to 3, so this head is no more here. So essentially it's a very small work. So first let's create a node temp. I'm assuming the Java syntax. If it is a C++ syntax, then we should create node pointer. In Java, node temp means reference itself. So we create a new node with value 3. Let's say value is 3. I am assuming a node class which has a constructor that accepts an integer value. So the node class will look something like this. For the sake of simplicity, we are keeping the data of node as integer, but you can keep it whatever you want, and ideally it should be templarized. It should be a template which can accept any type of data. Then we have node next, and we have a constructor also that accepts an integer value, and this constructor sets the data to the value, and let's say it set the next to null. So after this first statement, our list will look something like this. So list is still the same, just that we have a new node and temp is pointing to this new node. Now what we should do is that we should set the next of temp to the current head so that we don't lose the current linked list. So temp.head is next. Again, if it is C++, then temp arrow should be there, but since I'm using the Java syntax, so temp.next is head, and then head is equal to temp. So this head is now equal to temp, which means that head is pointing here. All right, so they are little overlapping. Let me just remove temp, right? Now depending on the programming language we are using, let's say if we are using C language, then we should be returning this head because we are not storing this head anywhere, and the calling function is the source of truth in a way, which keeps the head. If it is a Java language or C++ language where we have a linked list class, then inside the class itself we have the head pointer. So we should just update the head pointer and we should not return anything. So the signature of the function essentially depends on the programming language that we are using. In this case, I am using Java. So let's now look at the code. If you look at this code, then we have a class by the name myLinkedList. I have not kept the name linked list so that it doesn't conflict with the name present in the libraries. And then we have this RT-demo inside which we have a public main. In this class, we have a node class inside the linked list class, and the node class is pretty much what we have written. Then we have a head also. So this head should ideally be private and not exposed to the outside world, just to keep the object-oriented concepts relevant. Then we should have a constructor of this linked list class. So let's say this is the constructor of the linked list class, and in the constructor of the linked list class, we are just setting the head to null, which means that we are creating an empty linked list where head is null. Now after this, we will write our insert function. So I'm just copying it from here. So let's say the name of the function is insert at head integer value. So we are trying to insert an integer value at the head of the list, and I will just paste the code. So first we are creating a new node. Sorry, that should be temp.next and not temp.head. So here, this is my bad. It should be temp.next is equal to head and not temp.head is equal to next. and then we are setting the head to temp. So after this, after doing this, the new node with the data is equal to value will become the first node. Let's validate this by just printing this. So I'm writing a print list function which will just print the entire linked list in just a single line. So we are starting with head. For node temp is equal to head, while temp is not equal to null, which means that we will scan the entire linked list. So we are traversing the entire linked list, and what we are doing is that we are just printing the linked list. So I'm just printing the nodes in single line. So I'm using system.out.print instead of println, and we will just print temp.data, and let's also print some extra space after that. And maybe, just for cosmetic purpose, let's write list. All right, now let's try and run this code. So we will first create the object of the list, then we will insert the values in the list. So list dot insert at head, let's say 10, then insert at head. So after 10 we are inserting 8, then we are inserting, let's say 6, then we are inserting 5, and then we are inserting 3. So it should print in reverse order. It should print 3 first because 3 is inserted at the head, then 5, then 6, then 8, and finally 10. So then we say list dot print list. Now if I print it, then it should print the list in the opposite order of insertion because we are always inserting at the head. Let me just execute this. Alright, so output is 3, 5, 6, 8, 10 as expected. Alright, so the time that we are taking here is constant because we are only inserting at the head, we are not moving the head anywhere else, right? So we are taking constant time here. Time taken is on the order of 1, which is constant. Memory is also constant because the extra memory taken is not dependent on the size of the list. We are anyway not traversing the list at all. Are we handling the boundary conditions? So if head is null, then our program will work fine. So it will say that temp.next is null, so it will be null here, and then head will be the first node. So it is like inserting the first node. This is very important that during the interview and otherwise also while coding also, we should be handling the boundary conditions, and we should be consciously checking that we are handling the boundary conditions rightly or not. So here there are very few boundary conditions. One of the boundary conditions is what if the list is already null. Second boundary condition may be if the linked list has only one value, right? So we have very few boundary conditions. I just want to call it out that we should be explicitly putting checks for boundary conditions. All right, so this is pretty much we have in this very simple problem. And if you want to prepare for coding interviews or system design interviews, or you want to prepare for campus placements in your colleges, feel free to contact us. The contact details are given in the description. Thank you.